Hello, today we would like to present a mini project for computer vision, music detection, and visual instrument playback. This is our group member, so let's get started. The importance of the project. Music learning and production are often limited by a availability of skilled teachers, equipment, or accessibility tools. This project bridges the gap by enabling automated recognition of music notes from sheet music and providing instant playback using visual instrument. It caters to music learner, producer, and educator by using computer vision techniques. For the objective, to develop a system that detects and interprets music notes from music sheet score and play them through a user select visual instrument in real time. For the scope, first we detect note, basic note beats, length, and pitch. For the example, like whole notes, half note, quarter note, and for the pitch, like do, re, mi, fa, sol, la, ti, do. The second, using instrument sound during music playback, like piano or guitar. And for the third, using the program in real time. For the computer vision technique that we use and the reason, first, deep and super rays as a deep learning model for image upsizing. The second, convolution techniques for sharpen the image. The third, image reconstruction for opening, closing, erode, and dilate. The fourth, image segmentation for contour. Fifth, image thresholding for binary and binary inverse. The sixth, image recognition for template matching. And the seventh, image property extraction plus mathematical calculation. So let's go deep through each techniques. First, deep and super rays. This is OpenCV deep learning model which used for upscale the image while keeping the image quality. The reason why we use is the image resolution is varied. So using this tool will help us have a similar resolution image. This will keep us easily choose the kernel size for image reconstruction, image segmentation, since the image size are closer to each other. The next, convolution techniques. This technique used the kernel convolution to accentuating the edge for the image. Why we use this technique? The output image from the DNN super rays has blur edge, so using this technique help us to detect objects or edge more accurately. Image reconstruction. This technique is application for off-kernel to add or reduce noise into the image. And why we use this is the technique. This technique is used for pre-processing the image for finding a contour later. Image segmentation. For a contour is curve joining or continuous point. Why we use this technique? This technique can be applied to find the location of the object in the image, then crop or look into the detail of its location or area. Also, by using the area of the object, we can exclude the dot noise from the view of interest. The image thresholding. Thresholding is a technique to convert the grayscale image into a binary image based on threshold value. Why we use this? This technique can convert the image color value into black and white, which improves the accuracy in finding contour and morphology. Image recognition. Template matching is used to find a smaller image or template inside a larger image by comparing pixel intensity. Why we use this technique is because this technique is used for classify the music element by using template label name. Image property plus mathematics. Image shape, pixel location, and center points. We can use the property from image to calculate the relativity of some object in the image. And why we use this is because this technique helps us compare the location of the music step line, and music note head. Then we can define the pitch of the note. And this is overall flowchart. Here is concept of how we approach to the result. Step 1. Convert the piano sheet PDF file which located in the dataset folder, and then save it in the sheet folder which we consider it as a folder to store every music sheet project. As you can see, we use the name of PDF file or name of music song as a folder project name. In this step, we use two functions which are firstly, get file function to check if the PDF file exists, and the second, save convert file function is used for convert PDF to PNG, or just use the PNG if the music sheet is already PNG, and then save the file as a project. In step 2, we want the image with high resolution to make better image processing. Also, we want to use the image with the similar resolution, so we can use similar kernel for image processing. To satisfy this concept, we use function upsize image to increase image resolution. And in this step, we use OpenCV library called DNN SuperRes, which is deep learning model to enhance the image resolution while keeping the image quality unlike CV2 resize. In step 3, we use upsize image from previous step and input as an input, then sharpen the image to highlight the edge of the image so we can detect the light and the music element more accurately. We using function sharpen image function which using kernel convolution techniques. In this step, we want to extract the horizontal line which called step line. That is a line that In this step, we want to extract the horizontal line, which called step line. That is a line to match with node heads to identify the node pitch. In this step, we are using line detection function, which include in the OpenCV technique thresholding, kernel convolution, morphology. We use inward binary thresholding 170 since the image will be processed better in inverse color. Then we using morphology and kernel convolution to detect only long horizontal line. In this step, we extract the grand step. We want to look deep into the grand step, which contain melody line and baseline. We're using contour to detect the position of each step line, then sorting it from Y position, then separate it as a group of 5 step lines. In each group, we find the median Y position of 5 step line, then calculate the box dynamically to cover each grand step, then draw it on the copy of original image. Lastly, we crop each box to be grand step to deeper image processing. Here in step 6, we're using step position, which has similar method as line detection function. Then find the center Y position of each step line. Then using median of center Y position as the distance between each line, we call it as spacing. Then we're using the center Y position sort and dividing each 5 lines as upper and lower. Then we store the upper and lower step line position as list called step post. OpenCV technique that we use here is contour integrate with some calculation using the box position from contour. In this step, we want to capture our element for further template matching. We use the function step thickness A using box from line detection contour XYWH or step post B, then find the median and use it as step thickness. The second, bar line detection using kernel side to detect the bar line position B. Draw line using the position that we show with thickness equal W. The third, music element detection A. Subtract the detected step line, bar line from binary image B. Image reconstruction dilate closing opening to detect the music elements C. Using contour with limits area to include small noise from detection. And OpenCV technique that we use are first, thresholding, second, subtract image, third, image reconstruction, and fourth, contour. We're using template matching to classify clef, rooms, accidental key, and beat length. We detect from large to small template to avoid mismatching from small image. Every object that got detected, it will be removed from the object list to reduce runtime and to avoid duplicate matching. Functions that we use are clef matching, room matching, accidental matching, and beats matching. And for the OpenCV, we use resize image, crop image, and template matching. In this step, we want to assign the reference point in Y direction to identify what step control by slow key or far key. That position will be used later with spacing to classify the pitch. And for the code, first, separate upper, lower by ref point. The second, set a reference point and pitch at that point. To detect the node head, to get the center point for comparing. In this step, we detect the node head to get the center point for comparing with the step position later. For the function, we use node head matching to run through each the dictionary position. Template matching node head only for finding node head center point and store it as node dix. And for the OpenCV technique that we use resized image, crop image, and template matching. Here is the most complicated part of our project. The function for pitch classification receive input as first, node dix, which contain box of node head, bit type, node head center point. Second, base image for draw the box and label. Third, pitch indicator dictionary, which is the position of step line and its pitch that we gain from step 9. Fourth, step spacing that we gain from step 6. The idea of this step is first, get the center point from the node dix. Second, for each center point, check if it above or lower than half of image. Then set it as an upper or lower in order. Third, using step midpoint from the pitching indicator dictionary to identify the pitch from pitching list. Fourth, check the step pitch within the pitch indicator dictionary. Fifth, if step pitch equal G, then set the pitch list G as the show in the red square and start post. 6. Vice versa for step pitch equal F. As you can see, the list is inward from what it should be, since the Y position of image is counting from top to bottom, but we have to read the pitch from bottom to top. The 7. After we got the reference point for finding pitch, we calculate for spacing between each pitch, which equal to step spacing divided by 2. 8. Then we find the Y difference, which calculate from the node head center point Y subtract by reference position. 9. We calculate the time equal y difference divided by space. Then we write up to make a time variable as teenager imagine. If the node head center point is higher than the reference point, the y difference will be negative since the y of the image is counting from top to bottom. That is why we have to make the list backwards so the pitch can be in proper sequence C, D, E, F, G, A, B. 10. Now we will set new reference position by using reference position plus time multiplied by space. 11. Calculate error equal step spacing divided by 4. 12. We calculate multiply for indicate node pitch with higher or lower octave. 13. We using new reference position and error to identify if there is node head inside that range estimate ref post. Plus minus error, then assign pitch list post equal time plus start post divided by 7. Then assign the pitch to that node head by pitch equal pitch list. 14. Store the data into the dictionary. And 15. Annotate the box and label into the base image. For the step 12, for the setup, first import part, fluidSyn bin part. For using fluidSyn binary and sound font part, it is part of instrument sound. Notes frequency, MIDI notes for C sharp, D sharp, E F sharp, G sharp, A sharp, and B. And the third, note duration is set as the image show. To play music, firstly we group the note by X position by group node within range plus minus 20 pixels. Current group appends pitch beat multiplier. Append the current group to group node, then start new groups. If new detect nodes is not in range plus minus 20, return group nodes. Then we play the music by first we play all note from all node dix. Second, start fluidSyn and calculate bass duration. Third, loop and group node from left to right and detect longest beat. Fourth, convert pitch to MIDI number and adjust octave. You should know that the music will play after run through or grand step to get node dix. Node dix is append to all node dix. Then play back the music. And for the future work plan, we plan to make the application for user-friendly, adding more of the category of the music symbol, be able to detect the handwriting notes, be able to convert the sound into a note, and be able to detect other different musical instruments. And this is our GitHub. Next part, we will talk about detail of each function. In each function, we will show the flowchart, then talk about input and output. What is this function do? OpenCV technique and parameter and image output. Okay, let's start with main code, which we import other module from approach the music playback as we show. The input that we use are music sheet name, which collect as file input variable, and the path to save project, and part of data set. Lastly, popular path. In main function, we firstly use getFile function, which receive file input and dataset folder to check if the file exists, then return the file and its suffix, which can be PDF or PNG. Using the save convert file to receive file suffix dataset folder popular path to save the project file as folder that contains PDF PNG file, then return project path. Then the code will loop through the file with .png suffix. Those files will be detect the step line function, then extract the grant step and save it. Also append the grant step image to the all grant step list for later usage. Run through each grant step to process the image and generate the efficient data for pitch detection. Then save the noted annotated image. At the end, we will get the note dict which contain the note head position, beat, pitch, and multiplier. Then append note dict to the all note dict, so the music playback can play all the music song once the program analyzes through all grand step. Play the music from all note dict and set BPM at 60 to a slower song.
This is module 0 upsize image, and this is the flowchart. For the input and output. So what does this function do? It will check for the model file, which is here. Load the srcnn model. Load the images. Then it will ensure if the file is still in 8 format or not. Then it will perform upscaling and return both image. For the OpenCV function and parameter. And for the output, this is the original, this is upside, module 0, append image. This is the flowchart. For the input and output, what does this function do? It does apply a slight blur. Uses tv2.gaussian blur to blur the image slightly. It enhances edges. Uses tv2.add to sharpen the image by blending the original image with the blurred version. Then it will return the sharpened image. The final output is an image which improves quality and enhance edges. The OpenCV function and parameter we use. And output, this is upside, and this is sharpen. Module 1, get file, this is a flowchart. For input and output, what this function does, it reads file in the data sheet folder, use os.loader to get all file in the specified directory. Then it searches for the file, iterates through file, which is file name into file name and suffix, which is extension. Then it checks for match. If match is found, it prints file found, file name, and return file and suffix. If no match is found, print file does not exist and return 00. This is the output. Module 1, save convert file. This is the flowchart. Input and output. What does this function does? It creates an output directory, generate a subfolder inside sheet using the file name without extension. It processes the PNG file. It reads the image using CV2 image. It determines the upscaling factor based on the image list. It uses FSRCNN, fast super resolution convolutional neural network, to enhance resolution. Then it sharpens the image and applies grayscale thresholding to save the processed image in the output folder. This process PDF file. It converts PDF pages to image using convert from path. It applies grayscale conversion and thresholding. It uses FSRCN and upscaling to enhance resolution. Save each page as an image inside the output folder. It handles errors if image loading or PDF conversion fails. It prints an error message and returns home. The OpenCV function and parameters. This is the code. Here's the output. Module 2 line detection. Module 2 line detection input and output. What this function does, it loads the image from project folder as a grayscale image. Convert the image into binary black and white format using threshold of 170. Uses CV to H binary invert, making start line appear white. Detect horizontal line, use morphological operation with a horizontal structuring element. Extract line by applying CV to the morphology X with the CV2 morph open method. Save the process image. Create a folder grand staff image horizontal line inside project folder. Save the detected line as staff page num.png. Return the process image containing extract horizontal line. Module 2 line detection, OpenCV function and parameters. This is it. Output horizontal line. Module 2 construct extraction, and this is the flowchart. Input and output. What is this function does? It finds contour of the detected staff line to locate the bounding boxes. Calculate the line spacing dynamically based on the median. It groups every 10 staff line into a grand staff region by line per state to save per grand staff. It draw green rectangle around each staff and annotate them. It save an annotated image with grand staff region highlighted. It crop and extract grand staff region as separate images. And last, it returns the cropped grand staff image for further processing. OpenCV function and parameters. This is the output. This is module 2, save grand staff. This is flowchart. Input and output. What this function does, it creates a folder named grand staff image inside the given project folder. If it doesn't already exist, it iterates through the list of grand staff image. Generate a file name for each image in the format grand staff x png where x is the index of 1. Save each grand staff image to the create folder using cv2 invert. Print a success or failure image for each saved image. And method sorry. Return the folder path where the image is stored. Save grand staff, OpenCV function and parameter. So we use cv2 invert, file name and image. This is output. Module 3, staff position. This is for flowchart. Input and output. What this function does, it loads grand staff image in grayscale. Then it applies thresholding to enhance staff line with visibility. Then it detects horizontal staff line using morphological operation. And it finds a contour of detected line to extract bounding boxes. Then it will sort bounding boxes and compute spacing between them. It will identify the upper and lower steps based on line gaps. It will draw bounding boxes on the original image, green for upper, red for lower. It saves an annotated image highlighting detect staff line. Remove line using dilation and subtraction. Then it will select the clean image without staff line. Return extracted staff selection, detected line, clean image, and spacing. This is the function and parameters. This is the output. Module 3 bar line detection, and this is the flowchart. Input and output. What this function does is remove horizontal stab line to isolate vertical elements. It applies morphological transformation to smooth noise and enchant bar line. It detects vertical bar line using contours and filters out short elements. It replaces bar line with clean line for better visibility. It saves detected vertical lines and clean multi-key image. Heavy function and parameter. This is output.
So next is the module of music element detections. So this is our flowchart. And next is the input and output of this module. And what the function does, first it will finding the contour in the binary image here. And after that, it will removing the noise by filtering out the small contours. And after that, it will draw the bounding box around the musical elements that detected. And after that, it was saving the preset image with the highlighted elements. So this is our OpenCV functions and parameters. And this is our output. So our output will be the image of the music sheet with the box around the detected elements. So next is the module 4, cleave matchings. So this is our flowchart, and this is our input and output. So first is object post list, the list of bounding box position, base image, the main grayscale image, and project input, the path for saving the process, the file input, path containing the cliff template image, the GSNum, the index of the grant star for saving the results. So the output is object post list, updates the list after removing the detected cliff, the cliff dictionary, the dictionary storing the detected cliff, cliff detected image with detected cliff highlighted with bounding box and labels. And what the function does, first it will loading the cliff template files, and next it will extract detected musical elements here, and next it will resizing the templates to fit the ROI and applying the templates that matching. After that, it will select the best matching cliff based on similarity of tape threshold, and after that it will updating the detected cliff in the dictionary and removing from the list. After that, it will draw bounding boxes and labels on the detected cliff, and after that it will save the results. So this is our OpenCV functions and parameters, and this is our output. So next is the module 4, sharp pinch. So this is our flowchart for this module, and next is the inputs and outputs. So what the function does, first it will validate the staff positions to ensure that it has 5 staff lines, and next is it will identify whether the detected cliff is on the upper or lower staff, and next it will assign the pitch difference as a son or far, and after that it will mark the middle reference positions with the red dot, as you can see here. After that, it will save the annotated image to .indent.png. And this is our OpenCV functions and parameters. So this is our output. So it will save as middle the positions and pinch, and also the upper or lower staff. So next is the module 5, ring matching. So this is our flowchart for this module. And next is inputs and outputs for this module. And it will apply the templates matching. And it will select the best match similarity exceeds using the threshold 0.7, as you can see here. And after that, it will update the detected room type and remove the match object from the list and draw the bouncing box around the detected cliff. And after that, it will save the image and returning the update object list. So this is our OpenCV function and parameters in this module, and this is our output. So this is the module 6, accidental matchings. So this is our flowchart for this module. And next is the input and outputs for this module. And after that is the function task. First, it will load the accidental templates, as you can see here. And after that, it will iterate through the detected object positions for the ROI. And after that, it will resize the image, resize the image to matching the ROI. And after that, it will apply the templates matching. So it will select the matching best match if the similarity exceeds the threshold 0.7. And after that, it will store the detected accidental type and its position in the dictionary, and draw the bouncing box around the detected accidental in the image. And after that, it will save the final image and return the update object list. So this is our OpenCV functions and parameters in this module, and this is our output. So next is the module 7, beats matching. So this is our flowchart for this module, and next is inputs and outputs, and next is what is function does. So it's exactly same. So it will load the beat templates, and after that, it will iterate through the detected object positions for the ROI, and after that, it will resize
the image to fit the ROI. And after that, it will apply the template matchings. So it will identify the best matchings if the similarity score exceeds the threshold 0.6. And after that, it will store the detected beats in the dictionary with their types and center positions. And after that, it will draw the bounding box, center points and labels on the detected beats. And after that, it will remove the detected beat from the object post and save the results image. So this is our OpenCV functions and parameters for this module, and this is our output. So this is our next functions, node case matchings. So this is our flowchart for these functions. So this is the inputs and outputs. What this function does, first it will load node head templates, as you can see here, and after that it will iterate through the best regions, and after that it will resize the template to fit the ROI, and after that it will apply the template matching, and it will prevent the duplicating detections by checking the overlap bounding box. After that, it will store the detection with the beat type and draw the green bounding box around the node heads. And after that, it will save the image and return the dictionary. So this is our OpenCV functions and parameters using in this function, and this is our output for this function. So next is our next functions, pinch detections. This is our flowchart, and next is the inputs and outputs. So what this function does, first it will identify the staff are in the upper or lower staff. After that, it will use the pin reference of the staff to calculate the pins for each node case, as you can see here. And after that, it will calculate the shift in the staff lines to remain the correct pinch. After that, it will apply the error margin to ensure the node head is within the acceptable range. And next, it will assign pinch and offset multipliers based on the node vertical position. After that, it will return the update node head dictionary. So this is our OpenCV functions and parameters using in this function, and this is our output for this function. So next is our next functions, same pinch annotated. So this is our flowchart for this function, outputs and inputs. Inputs for node head dictionary, JSON, JSON project path, and outputs for save path. So what this function does, first it will convert the grayscale image into BGR, and next it will iterate through the node head dictionary to access the positions and the pinch. And after that, it will draw the bounding box and mark the center points with red dots. And after that, it will label the pins of each node near its position. And after that, it will save the annotated image and return the path of the annotated image saved. So this is our OpenCV functions and parameters using in this function, and this is our output. So next is our last functions, play music. So this is flowchart for this function, and this is the input using in this function. And what does this function does? So this is our final functions to play the music. So it's using FluidSynth. First is we begin with initializing FluidSynth and setting the base durations, as you can see here. And the functions process is grab staff from the list, dictionary, and group nodes by their X position to handle simultaneous nodes, as you can see here. And for each group nodes is convert to the detected pinch into the medic nodes and apply octave scaling based on the multiplier here. So the code is in here. And for the functions, it will calculate the node durations and play the nodes together, ensuring they all place for the longhand nodes in the group. And after that, it's wait for the nodes 2 minutes before stopping them, and after processing all the grab staff, the function will stop, fluid syncs, and end the playback. So this is the OpenCV functions and parameters using in this function, and this is our input, so you can turn up the volume. So that's all for our presentation. Thank you so much.